Assalamualaikum. Today, my group will present about application of differentiation on how to calculate the maximum area of Corral. Our group consists of 3 members. The first is me. My name is Amirul Ashraf bin Muhammad Rafi. That we present about introduction of our topic and early calculation. Second one is Muhammad Daniel Hakim bin Zulkifli, who we present about the next calculation. After that, Muhammad Ifan Hakim bin Halim we present about the next calculation and the conclusion of our topic. In our real life, finding the maximum or minimum value of a real world function is the one of the most practical use of differentiation. In our case, we are trying to do things like maximize or find the least amount of material to make particular object. So, we must use the differentiation to calculate the maximum value. Maximum in mathematics, a point at which a function value is greatest. Technique for finding maximum and minimum point motivate the early development of calculus and have made it easier to solve problems such as finding the dimension of container that will hold the most for a given amount of material used to make it. So, our problem statement is find maximum area of a corral given a certain length of fencing. Say that a rancher can afford 300 feet of fencing to avoid corrals that divide into 2 equal rectangles. So what dimension we maximize the corrals area? So the first step is we must express the thing you want maximize the area as a function of the 2 unknowns x and y. So what we get here is area is equal length multiplied with width, which is 2x multiplied with y. This is because the area is a function of 2 variables. Step 1 has 2 additional substeps. So, the next step is we use the given information to relate the 2 unknowns to each other. So, the fencing is used for 7 sections. Thus, 1, 2, 3, 4x and 1, 2, 3y. So, 4x plus 3y is equal 300 feet of fencing. So, y is equal to 300 minus with 4x over 3. So the next calculation will be continued to Daniel Hakim. So that's all from me. Thank you.
Now I will continue from Amirul. That's given the equation of y 100 minus 4 over 3x, and now we have to find the function of one variable that is x. So I will use the formula of area. It is length times by width. Length represents to 2x and width is y. So y, the value of y, we can substitute from above. Now we get 2x times 100 minus 4 over 3x. And now let's calculate. We get 200x minus 8 over 3x squared. So this is the function of ax. Okay, now we know that the fence will never get the negative value. So the x will never get the negative value. And now we have 4 sides and the maximum length of the fence is 300. So we can divide it by 4. We can get 75. So 75 is the maximum value of each fence. So now we know the domain is x less than equal to 75, and also 0 is less than equal to x. So this is the domain of the function. Now from the function given, that is 200x, minus 8 over 3x square, we will calculate the value of critical numbers of the x between the interval 0 and 75. So now, to get the value of x, we will use the differentiate. So 200x minus 8 over 3x squared, we will get 200 minus 16 over 3x by using power rule. Then when we calculate all of the numbers, we can get x is equal to 37.5. So this is the critical value of x.
Assalamualaikum and very good morning to everyone who watching this video. I'm Muhammad Irfan Hakim bin Abdul Halim and I'm the last member of this group. I'm gonna present about the last calculation and the conclusion of this topic. In the last calculation, we need to evaluate the function at the critical number 37.5 and at the endpoints of interval 0 and 75. If the value of x is 0, the area will be 0, and if the value of x will if the value of x is 37.5, the area will be 3,750, and if the value of x is 75, the area will be 0. The maximum value in the interval is 3,750 and the value of x 37.5 will maximizes the area of the coral. The length will be 2x or 75 feet and the width is y, which is equals to 100 minus 4 over 3 times x. And if we plug in the x with 37.5, the value will be 50. So the ranchers will build a 50 width times 75 with a length of corals, and the area will be 3,750 square feet. This is the real world situation where it pays to do the math. Had the rancher not solved the problem, he would likely to build a smaller size of coral. Many people know that a square often maximizes area. This would be the case. For example, in a similar coral problem where there is no dividing fences in the middle of the coral, so the rancher might have should build a square coral or rectangular coral made up of two squares. In a conclusion, we know the importance of differentiation in our life, in real life. In this problem, we know how to use the differentiation to calculate the maximum area of a coral. This is very important because when we need to make something, we need an accurate value so that the thing that we make are suitable and stable.